Is that the title of 3.1? You guys got it right there? Extrema. What word do I want you to think when you think of extrema? Extremes. In extremes, think of mins and maxes, right? Two different types, absolute and relative. Two different types, absolute and relative. I had a big old graph on the board. We talked about how relative extrema inside a graph in between two endpoints, whether it's open or whether it's closed, open, holes, or closed. Relative extrema will always happen at horizontal tangent lines or sharp points. So therefore, they're always going to happen at, what, the wrong direction, at critical numbers. So we talked about the fact that we need to find when the derivative, which might be a fraction, when the derivative is equal to 0 or dne. Now question, will every single derivative have dne places or points?
No.
No. Take the derivative of x squared. What do you got?
2x.
That doesn't have any undefined points. Just set them equal to 0. There's not even a denominator with the variable. So 2x, just find the zeros. He won't have those. But if you have a fractional derivative, you've already taken the derivative, there's a top, there's a bottom. Be sure to not only look for the zeros at the top, but also the undefined at the bottom, in order to keep an eye out for those possible extrema. All relative extrema. Inside endpoints, all relative extrema within a graph are going to happen at critical numbers, but not all critical numbers are relative extrema. Can anyone think of a way that there could be a horizontal tangent line and not be a min and not be a max?
Kind of swept off.
Some people might have seen some of the homework last night.
Yes.
Woo! Where's the horizontal tangent line?
There. Yes.
So when you solve the derivative equal to 0, guess what? This one would show up, but is he a min or max? No, so we do have to learn as we progress on. We do have to learn actually in sections 3, 3, 4, how to find relative extrema from the critical numbers. But I can say every relative extrema within a graph, within an interval, will come from critical numbers. Just keep an eye open when you're looking at graphs and homework and they say find the critical numbers. Not every one is going to be a min or max, because if I was to take this graph, remember, to be a relative, you have to be able to take the region right around it. Is this the highest of the region right around it? No, it goes higher. Is this the lowest? No. So of the region right around it, not the relative or the local. Those are synonymous, min or max. Sarah, do you have a question?
Yeah, when I was doing my homework, every time I found an absolute, it was also a relative. Is that the case for everything?
Yeah, let's go ahead and talk about this graph, because that's going to help out. So we finished talking about critical numbers. Let's zoom in on the graph. We didn't finish labeling stuff yesterday. Question. The very first point that we identified, this one over here. Oops. One page up. There we go. All right. Why is he the absolute min? He's the lowest one. Now, some textbooks would call him a local min. Ours, to be honest, ours does not call him a local min because they save local minimums for within a graph. They don't allow them to be at endpoints. Some books would do a special definition and say if you cut it off, only come from one direction, but that's okay. We're just going to go ahead and ignore that for right now. We're just going to call him an absolute min. This would technically be an endpoint. This is not a critical number. Which of these would be critical numbers, kiddos? Where the derivative, the slope of the tangent line is either 0 or dn?
The second, the third, and
The second and the third and the this one. So that's a sharp point, right? That'd be a dne. So this one we could say is a critical number. Specifically, the derivative equals 0. This one we would call a critical number. The derivative equals 0. And this one we would call a critical number. The derivative equals? Does not exist. Good. The derivative does not exist. That one's a local max, because if I was to draw a circle, he's the highest of his little region, right? This one is, oh, we haven't identified him. Who's this guy? Yeah, he's a local minimum because, why is he not an absolute? There's a point that's lower, the absolute.
How do you know what's the region that you're considering?
Oh, for local, it's just a little bit before, a little bit after.
Like 1 point? Like, how do you know how far to go?
Oh, for the entire thing, we're looking from A to B. So we're just looking at the entire section. But when I say a local, I'm saying he doesn't have to be the highest of everything. He just has to be the highest of his little area. So it's not really like a defined area. It's just look a little before and after him. Oh yeah, he's the highest. A little before and after him, he's the lowest, which is pretty logical once you get the feel for it. This guy. Good. But, question from Sarah's, is it also a relative?
Yeah.
So if you just took his little region, he's the highest. So he is a relative or he is a local. But if you look at the entire thing, he's also an absolute. So this guy is going to be two things. He's going to be not only, there we go. He's going to be not only a local, but he's also going to be an absolute.
Wait, so would that be an endpoint as well?
Yeah, I don't think you have room for this.
No, right?
No, it wouldn't be.
Yeah.
So is local synonymous with relative?
Yes, local is synonymous with relative. Because just think relative, if you talk about, like in a philosophy class or in like a Bible class, if you talk about relative truth, what are we talking about? Multiple truths, but that's not exactly what relative means. That's more of an application.
Subjective to interpretation.
Yeah, subjective to interpretation. Relative truth, it's true for some people or true sometimes. If you're talking about something that is relatively true, there are conditions on it. Sometimes it is, sometimes it's not. So, if you're thinking about relative, it's like, oh, sometimes for some areas. So I'm saying for some area, local is a little bit easier because it's like, oh, the area right around it. Relative and local both have some idea for a limited area, it's good. So for a limited area, yeah, it's the highest. But also for the entire, it's also the highest. Because an absolute truth, always true, or always the highest for the entire. This wouldn't be an endpoint, that would be a critical number because of the DNE. But what is an endpoint? This guy. So he is an endpoint, I would call him that. The question, is he an absolute min? Absolute max? No.
Local.
Local, some books would say yes, because if you just went from one side, you just wouldn't look at the other. Some books would say local, but ours says, nah, it's not a critical number, so we're just going to go ahead and leave him off. Now, if you look at this graph, guys, where did the absolute min end up being? An endpoint. Where did the absolute max end up being? Critical number. So then I want you to look at the absolute, the extreme value theorem. The extreme value theorem. And I want you guys to think, with the extreme value theorem, which we could abbreviate EVT, I need you guys to hold in the idea absolute. The extreme value talks about absolute in multiple ways. Number one, it guarantees absolute extrema if the function is continuous on a closed interval. If you have a closed interval and it's continuous. Yesterday we saw at holes, we have to say, uh-oh, the hole would be the highest, we can't count it. So to be careful, but if it's a closed interval and the function is continuous, no jumps, no holes, no vertical asymptotes in between, then we can say it will have a highest and it will have a lowest, which means the highest, the lowest, absolute. However, this card is also helpful, even if you have a discontinuous function or if you have a non-open interval. Well, let's leave it with the continuous and the closed interval. It also helps us find the absolute min and max because it says the extreme values, aka the absolute extrema, will occur at either endpoints or critical numbers. So, to find absolute extrema, test the candidates in, oops, I can't type, I'm writing, in, I can't spell.
Can't speak.
Thank you, that was not working out so hot.
It's an abstract.
Nope. In alphabetics.
Do you plug in your critical numbers to?
Yeah.
Okay.
So we're going to use the derivative to find the critical numbers. The endpoints are going to be given to us, but we're going to take both the endpoints and the critical numbers for a continuous function on a closed interval, and we're going to test those candidates, the endpoints and the critical numbers. We're going to test them by plugging into the original function, and hopefully we get to some examples where you guys will notice why we're testing them by plugging into the original and not the derivative. It's not about the derivative to be highest or lowest, it's about the y values.
That's for checking for holes, right?
Who has the, well, I was saying for a continuous function. If we have holes, etc., we actually have to get further into the chapter to talk about something called a sign chart, where we talk about the increasing, decreasing. We have to actually think about how the function moves because it's not enough to only look at critical numbers and endpoints if we have discontinuities or an open interval. Because all bets are kind of off. Kiddos, just looking real quick. I didn't even give you functions. I gave you quick little sketches. The absolute extrema, does it make sense? He's the absolute max and he's the absolute min,
Yeah.
right? And what kinds of points? Which of the candidates?
Critical number.
Yeah, both of them will be critical numbers, right? Absolute max, absolute min, you would find them by taking the derivative and setting equal to 0. How about this guy? Absolute max, absolute min. Okay, both of them are at endpoints on this one, right? Would you find them with the derivative? No, because there would be no zeros. Look, there's no flat places. There's not even any sharp points. So first, it doesn't have any critical numbers, and second, the absolute extrema occurs at the endpoints. Now what's going on here though?
Endpoint.
Absolute min is going to be at an endpoint. And absolute max is going to be at a critical number. This is just visualizations of whenever you have any sort of continuous function on a closed interval, the absolute extrema will always occur at either the critical numbers or the endpoints or some combination of the two. But how do we know who's who if we don't have a function graph? If we found these x values, couldn't we plug it into f and say, hey, how high is your y? The high one will be the absolute max, the low one will be the absolute min. If we tested the endpoints, wouldn't he have been lower? Wouldn't he have been lower also and higher? He would have been the highest if I plugged into the y's, and he would have been the lowest. I'm saying, hey, how high is your y? Over here, how high is your y? The highest one, absolute max, the lowest one, absolute min. There were no critical numbers. These guys, I would have tested him and him and him. How high is your y? He had the highest, he had the lowest.
Wait, so for the third one, would that be an endpoint as well?
This would be an endpoint, but he wouldn't have been, or he wouldn't have won either of the absolute titles. Does that make sense? So, think about it. How high
Is what?
is your... But who? These guys. We're only testing them. So, steps for finding absolute extrema. I'm not going to make you guys make a forever card out of it. We pretty much just put it on the last card with the extreme value theorem. But this is like a little bit more drawn out. And I think pretty much the rest of today we're practicing. Sorry, the air turned on. It's nice and warm for a little bit.
Why did you say how hard was going?
Because I forgot to change it before I put it on. I know, isn't it so sad? So it's Messiah, Nicaragua. I know. Mom said yesterday that, because we were emailing back and forth. She was like, so let us know if you're not using some of those spots, because every single trip, every single day, except for Santiago, it's completely packed with waiting lists.
John actually put me down on the slide for me. When I asked him what the plan was, because I told him about what, like,
John who?
yeah. Something like car.
The team cancels last minute. They should get him on board and be like, hey, let's just go to Nick. No, Corey loves Jen. And you guys build relationships. John loves him. Daisy faced with me yesterday. Yes, we're talking about mission trips, and they're really awesome experiences. We have applications on the back table and a yellow flyer that is all correct except for when it says DR is where we're going, because we're not, but it says Nicaragua, so anyway, heads up. If you want to still try to sneak in, deposits aren't due until next Wednesday. All the info's back there. We would love to have you. And pick it up and ask parents. You never know. God's already changed one hard father's heart this year. He never wanted his kids to go for the last 6 years. Finally, his youngest is like, never know. Okay, steps. Absolute extrema, the min, the max. Find the critical numbers. How? Take the derivative, just so we have it in one place, at the top equal to 0, bottom equal to 0. If there's no bottom, no big deal. Just set the whole thing equal to 0 and do that. Evaluate f at each critical number. Evaluate f at each endpoint. Guess what? We're going to make a table. We're going to make a candidate table. Gotta test the candidates. They all put their applications in, but there's only one highest, one lowest. The extremes win. The greatest is the absolute max, the least is the absolute min. So it's kind of just getting it in one place in your notes you can open up to tonight when you do homework and say, this is how I do it. Isn't there a song? Never mind. Okay, ready?
It gets so cold in here.
I know, I'm sorry, the fan's on. Nope, still going? Okay. If you have your phone, take a picture.
No.
You sure?
Yeah.
If you have your phone, you take a picture too.
Quick, David, take a picture. Take a picture, David.
I'm zooming in. I'm zooming out. Because all my pages, I don't know why they're all weird. Okay. Zooming in. Zooming out. All right. Oh, just find the critical numbers. Guys, we don't even have to do the candidate test. Okay. Critical numbers, what are we going to do?
Find the.
This is why I said start homework.
Yeah.
It's okay, maybe you just learned for tonight.
Find
But
the.
almost every single section has you finding derivatives as the first step in a problem. There's more.
Well, it's D.
Can it take time to take derivatives? Yes. So you have to start early. Just doing what you know, having it ready for what you need to use it for. Okay, guys, I'm just going to go. All right? I'm just going to go. Get down to functions, and then I'm just going to go for both of them. You guys can go too. Or if you want to just copy down what I have to make sure you have it right.
Ready, set, go.
No.
I have no idea. That's it. You fine. I'm going to come back to that one.
You done it.
Second, D first, plus first, D second. Ooh, that's a good rule. Ooh,
I don't know.
derivative of b to the u is b to the u, boo. Limb, ln of b. Ooh, but you find this one.
So do we set equal to 0?
Kinda. He doesn't have any denominators, right?
Yeah.
Okay, so he's just equal to 0. Because this is g prime. He doesn't have any denominators, so he's just equal to 0. No stress. This guy, though, he has a denominator, right? But question, is there a nice top and a nice bottom right now?
He is. Well,
No.
not nice. Oh.
I need to get them to be a common denominator. I know, but it's algebra. So I'm going to multiply this guy, 5,
So you can use. Oh.
2 square root of 4 minus t, all over 2 square root of 4 minus t. Oops, t. Nasty, but I didn't have a lot of room. Why? Well, I would love, a square root times a square root goes away. I would love to have one top and one bottom, because why is it so nice to have one top and one bottom? Top equal to 0, bottom equal to 0. Awesome.
Is that really you can't rewrite the problem to like 4 minus t to 1/2? Is that really easy?
If you put it to the 1/2 power, or even to the negative 1/2 power, the problem is then you won't even see the denominator, so it's going to get you all messed up. So you want to rewrite it. I mean, you could have done 1/2 power and then had the negative 1/2, but rewrite it in a way that your brain comprehends. It understands fractions and square roots for going and plugging in and solving. So get it into that form that's easier on your brain. Get it with a common denominator together, so that then you can say, oh sweet, top equal to 0, bottom equal to 0, let's go. So, yeah, solve for t. It's like x. Solve for t, solve for x, solve for the variable. Up here I end up with 8 minus 2t minus 1t minus 3t, right? On bottom. Top equal to 0, bottom equal to 0. I end up with t equals, I have a horizontal tangent line at 8/3.
Yes.
And I have a sharp point at 4. Now hold on. Is there anything based on either what's given or the domain that I should ignore right about now?
4.
Why should I ignore the 4?
So it will be less than 3.
But is 8/3 less than 3? 9/3, yeah. So the only critical number in this interval, sometimes you have to think about the interval, if they give it to you. The only critical number is 8/3. And specifically what type? He's a horizontal tangent. Why? Because he came from a 0, not from a DN. How do I find, oh, sorry.
Sorry, really quick, why is it not 4 again?
Oh, they said t less than
Oh.
3, so the graph is being cut, so I just ignored it. Now, guys, how do I find zeros when there's all kinds of weirdness?
Isn't it all just multiplication, so it's just 0? Or x is...
Product rule, there's an addition.
Shoot, no, I didn't see that.
Since there's an addition, though, that's
Well,
a
you
good
can
thing.
just still-
Factor.
Can you...
Always try to factor.
Yeah.
What's in common of these two guys? Yeah, 3 to the x is in common, and what else? 4x. Who's left? Well, there's a 2. And I took out 4x, and x, ln of 3. No. Every time you have factors equal to 0, I set everybody equal to 0. So he gets equal to 0. I know it looks funnier than things that you've seen before, but you still have to set all the factors, this guy, and that guy, and that guy, all equal to 0. Now, here's the weird thing. If you took ln of both sides, solve for the x,
Is it ln of 0 doesn't
can an
exist?
exponential ever hit 0?
No, so
No.
then it's...
ln of 0 will always be dne, which means an exponential can never equal 0. You always ignore him. He can't ever be 0. He skims 0, but he never will hit 0. That one, oh yeah, that's 0. And then this one, ooh, subtract the 2, divide by ln 3. It's gross, but it's right. There's no domain restrictions up above, either implicitly or explicitly, either implied or given. So those are my 2 critical numbers. Okay? Skip however much space you need, because I gotta go on to an absolute one. Whew. Here we go. To be honest, I'm not sure if we'll have time for both, but we'll do what we can. And all you guys basically need is just to do one. We might do the other one in workspace tomorrow. Oh, I have 2 other ones for workspace. I'm gonna go for it, guys. Let's see if we can do it.
Do one primarily.
Up front.
She's going ham.
Okay, I just found a derivative. He's a nice little polynomial, right?
Yeah.
I did a joke. So, no denominator, no stress. Set them equal to 0. So my critical numbers are going to be, well, couldn't I divide by 6, so it's x squared minus 1. Wouldn't that be plus or minus 1?
Yeah.
Add the 6, divide by 6, square root plus or minus. Now hold on. What's legal in my interval? My endpoints are 0 and 3. Well, then the negative 1 isn't going to be 1, right?
So it's just only the minus.
Exactly. So I'm going to go ahead and write out the negative 1, positive 1, but we're going to cancel out the negative because he doesn't fit in the interval. I'm going to go ahead and take the first endpoint, the critical number in between the next endpoint, and say, how high is your y, right? How high is your y? We'll plug him in. Plug in 0. Well, his y is a 0. Plug in 1. Double check, negative 4. And plug in 3. Ugh. $36? So the absolute max is 36 at x equals 3. And the absolute min is negative 4 at x equals 0.
X equals 1.
Oh, woo, woo, that was close. X equals 1. That's the idea. Take a derivative, find critical numbers, and if it says absolute extrema, take endpoints, take whatever critical numbers are in between. The others we don't care about. We'll be looking at the one portion. We don't need to know the graph. Just ask how high is your y. Highest wins, absolute max. Lowest wins, absolute min. Now guys, look. If I'd had time, I would have done 1, 2, 3 more problems. I would have done 1, 2, 3 more problems. But otherwise, we're done. So, to finish off, let's have you guys write down homework. That way, if you have time today, you can already start it. Sound good? You take a picture of it on your way out. Ready? Ah, that's not it. There we go.
Homework's so hard.
Yeah.
Instead of rushing another problem, remember you can trick or treat on the way out. Although, I won't let you do tricks, and I won't do tricks. Bye guys. Oh, sorry, it's very zoomed out. But if you want the whole chapter homework page, you can grab it now.
No, I hate God.
David, do you want to refrigerate that? I can make room.
Yeah, could you?
Yes. I got you.
Thank you for like.
Someone want to pause the video? I would really appreciate the pausing.
Kit Kat's the best.